Hi, Mrs. Stanley here. Let's talk about oblique or slant asymptotes. The objective is I can identify oblique asymptotes and write their equation. So first, let's just talk about what is that. When the degree of p of x, remember that's our polynomial on top of the function, is exactly one more than the degree of q of x. Remember, q of x is the bottom polynomial in our rational function. Sorry, that looked a bit sloppy. The graph will have a slant or oblique asymptote. It's the same name, or it's two different names for the same thing, slant or oblique. Look at the diagram here on the right. You see the dotted line? It's an oblique asymptote. We call it a slant because it's like a slanted line. Here's how we find it. The equation of the oblique asymptote, y equals mx plus b, is the quotient of p of x over q of x, ignoring the remainder. What does it mean to be the quotient? You divide them. We divide p of x divided by q of x, and we just ignore the remainder. That's what gives us the equation for that slanted line. So let's look at some examples of what that means. It's going to be easier probably than you think it is. Let's look at it. Use long or synthetic division to divide p of x by q of x. Number 2, write the equation of the oblique asymptote using the quotient, ignoring the remainder. So let's look at number 1 here. Notice that on top we have x squared and on bottom we have x. 2 is exactly 1 greater than 1, right? 1 plus 1 is 2. So x squared is exactly 1 degree higher than x. So that's how we know there's going to be a slant asymptote, and we need to divide. We can use synthetic division because look, here's the x. The leading coefficient is 1. And so we're just going to do synthetic division. So we're dividing by -4 because remember x plus 4, we got to change the sign, and then we put all of our coefficients. So we got 1, -1, and -14. Bring down the 1 times -4 is -4. Add these together is -5. -5 and -4 is 20. -6. Now remember, we said we're going to ignore the remainder. So all we're using is this information right here, y equals x minus 5. This is the equation for our slant asymptote. This is what we mean, okay? Let's try another one just to double check. Here we go. Number 2, x squared and x. Again, it's exactly 1 degree higher on top than on bottom. So again, we look at our leading coefficient here is 1, so we can use synthetic division. X minus 3 means we're dividing by 3. And we've got our numbers up here. We've got 3, -7, and there is no constant, so we're just going to put the 0 in there. And so we bring down the 3. 3 times 3 is 9. Subtract these two, we get 2 times 3 is 6. We've got a remainder, but again, we're ignoring the remainder, right? And so our answer is just going to be y equals 3x plus 2. This is our answer, okay? Now when we jump down to number 3 is where we're going to run into the problem that we can't use synthetic division. We're going to have to use long division. So we've got to write the 3x plus 2 on the outside, and then the whole upper polynomial on the inside. And then we're just thinking this through. What would make 3x equivalent to 6x plus 2? Well, we'd have to multiply by 2x. So 2 times 3 is 6, and x times x is x squared. 2 times 2 is 4. And then we need to subtract that out. And so this is going to be 6x squared minus 6x squared is 0. 4x minus 4x is 0. So we have 0x, and we bring down the 11. So now what's going to give me 3x to make it, what's going to make 3x equivalent to 0x? Well, I'm going to have to multiply by 0. And so I'm going to get 0 again, and this is going to leave me a remainder. It's all kind of weird, but you can see the remainder is -11, but we actually already said that we don't care about the remainder, so that's going to be gone, and all we are left with up here at the top is the 2x, so y equals 2x. And then coming to the last one, I would encourage you to look at doing this yourself, but come back and check your answer as you're going. Remember, we are doing the top divided by the bottom. So don't look at this and suddenly switch it up because the top has less terms. It's still what's going to go on bottom because notice it's a higher degree. So outside I've got x squared plus 2x minus 3. Inside I've got x cubed plus 3x squared plus 0x plus 0. And we do need those terms. So how am I going to get x squared to be x cubed? I'm going to multiply by x. So let's do all that. X times x squared is x cubed plus 2x squared minus 3x. And this is all going to be subtracted. 3x cubed minus x cubed is gone. 3x squared minus 2x squared is x squared. 0 plus 3x. Bring down that last 0. X squared times x squared, all I'm going to need to do is multiply by 1. 1 times x squared. 1 times 2x, and 1 times negative 3. So we can just work this out. 3x minus 2x is x plus 3. But again, we don't need the remainder, right? So the remainder we're just ignoring, and we are left with y equals x plus 1. So now we're ready to go down here and actually look at graphing some of these oblique asymptotes. And in order to do that, some of this information is going to be exactly what we did in the previous lesson. And so you'll use those same rules, but now we're adding in the oblique asymptotes. Because you notice over here you've got domain and range, x and y intercept, vertical and horizontal asymptotes, and then slant asymptotes is the SA and none, and the holes, which could be none or there could be some. So the first thing we want to do is the same rules that we did in the previous lesson. We want to go ahead and factor this. X squared minus 9 is a difference of squares. So we've got x plus 3 and x minus 3 over x. So that's going to be the simplified form. But notice from the beginning, x squared over x, the numerator is 1 degree higher than the denominator. So that does tell me there's going to be a slant asymptote. And I can go through the rest of my problems here just to check, find my information and check for any other asymptotes. So let's do that. So looking at the numerator for p of x, x plus 3 and x minus 3 is going to give me my x intercepts, and that is going to be negative 3 and positive 3. I could go ahead and graph those, negative 3, 0, and 3, 0. Those are my intercepts. And then what about y-intercepts? When will the equation equal 0? I keep saying that incorrectly, not when the equation equals 0. What happens when x equals 0? To get the y-intercept, we do f of 0, and that would be 0 minus 9 over 0, which we can see doesn't happen. So there is no y-intercept. And then we can do vertical asymptotes. How do we find the vertical asymptotes? If you remember, we found the zeros of the bottom, x equals 0, right? The bottom is x, so if x equals 0, there's going to be a horizontal asymptote. So what would that look like? Well, the horizontal asymptote, it's a vertical asymptote. My goodness, I'm just confusing you guys. I wrote it in the vertical asymptote. It's this way. This is x equals 0, okay? And then horizontal asymptote. Is there a horizontal asymptote? Well, we can go back and look at the degree situation. If you don't remember, it's in the notes from the previous lesson about graphing rational functions. So to get a horizontal asymptote, if the degree of p is greater than the degree of q, there is no horizontal asymptote. So if you just write none, there is not one in this case. Is there a slant asymptote? Well, we already said that x squared is 1 degree higher than x, so we're going to have to do the division, and fortunately the bottom has a coefficient of 1, and so we can use synthetic division, and we've got here we have 0 that we're dividing by, and we have x squared, which is 1, we have 0x, and we have negative 9. So here's our coefficients. We bring down the 1 times 0 is 0, subtract those. 0 times 0 is 0, negative 9 plus 0 is negative 9, and so what are we left with? Well, remember, we ignore the remainder and we're just left with y equals x. Right? Because this is 1x. So the slant asymptote in this case is y equals x. And if you remember, y equals x is the line that looks like this. So this is our slant asymptote. And then the last thing, are there any holes? There were no factors, common factors in the numerator and denominator, so there is no hole. So that's done. And then what about the domain and range? Well, we already said there's a vertical asymptote at x equals 0, and that means that in the domain, x such that x cannot equal 0, right? And then for the range, there's no horizontal asymptote and there's no holes. So that means there's nothing. And then if we also look at, there's no other reason that we couldn't have any other value for y. So the range is all real numbers. And then we need to try to graph this. And this is where it gets a little bit harder. You probably feel like, wait, I need more information. It's basically going to look like this. It's going to curve towards, let me change the color. So we have a third color, because we've got, remember, our green dotted line vertical asymptote and our orange line. So we have the x-intercept. It's going to come, I'm not sure what happened here. It's going to come like this, and then it's going to come towards this asymptote, and then this one is going to do the opposite. It's going up here and coming towards this asymptote. So it looks similar to this. Did I get any other exact points? I did not. We could have looked for some, but we don't really have to. If you wanted to, you could just plug in, for example, I could plug in the 1 to see what is this point. I could plug in the -1 to see what is this point for x times what I'm talking about, and get some values if you're a person who really likes your graph to be precise. But in this case, it is not required. This is close enough, okay? So I want you to try number 6 on your own. Remember, factor to simplify, all of that. Use the division to find out what the slant asymptote is, if the degrees are there. Since that's what this lesson is about, and there's only 4 problems, you can assume that it's probably there. Then I will jump down and do number 7 with you, because it is a little bit harder, just meaning that it has long division. So let's look at number 7. We've got 6x squared plus 11x minus 10 over 2x minus 1. The first thing that we're always supposed to do is factor. How does this factor down? Well, with 6x squared minus 11x plus 11x minus 10, you're going to get 2 different factors, 2x plus 5 and 3x minus 2. Because remember, notice that the 10 is negative, and we've got to get the 6, so that's the 2 and 3x. And then on bottom, we still have 2x minus 1. Notice that there's nothing that cancels out, no common factors, so I can immediately go ahead and say there's no holes. That's easy enough. And then we need to do the synthetic division, because look, I've got x squared on top and x on bottom. That's 1 degree difference. So that's what I need to check for slant asymptotes. What about vertical asymptotes? We can figure out the x-intercepts, y-intercepts, all of that. Let's do that. So x-intercepts, we've got 2x plus 5 equals 0 and 3x minus 2 equals 0. So let's go at, sorry, I tapped the eraser. 2x minus 5 equals 0 is going to give me x equals 5 over 2. And 3x minus 2 equals 0. I'm going to add 2 to both sides, so I'm going to get x equals 2/3. So that's going to be my x-intercepts. So I've got negative 2.5, 0, and 2/3, 0. We can leave that one as a fraction. And I can go ahead and plot those. Negative 2.5 and 0 is right here. 2/3 and 0 is about right here. So we've got those. Is there a y-intercept? What do we get for f of 0? If I've got f of 0 equals 0, 0, so we've got negative 10, and 2 times 0 over negative 1, so it's 10. Is that right? Yes, the y-intercept is 0, 10. Is that going to be on our chart here? Don't we stop at 8? So it's going to be like up here if we were going 2 more. So that's not going to help us a whole lot, but that's okay. We'll leave it just so that we know it's there. So the y-intercept is 0, 10. And then vertical asymptotes. Remember how to catch that? We find the zeros of the denominator. So when does, let me change color again. When does 2x minus 1 equal 0? Well, that would be at x equals 1/2, right? At x equals 1/2. So that's going to be our vertical asymptote. And how do we draw that exactly? It's going to be really tight, because remember, this point that we drew is at 2/3. So this is our vertical asymptote at 1/2. That's hard to make a straight line. X equals 1/2. Horizontal asymptote, remember the degree of P is greater than X, and so we said there is no horizontal asymptote, but we know that there is a slant asymptote, and that's when we need to bring in long division, which I don't really have room for. Let me clean this up a little bit. Okay, I just sort of shrunk that down to give myself more space. So I'm going to be dividing 2x minus 1 into 6x squared plus 11x minus 10. To get 6x squared, I'm going to have to multiply by 3x, and I get 3 times 2 is 6, and x is x squared minus 3x. I've got to subtract all of this. 11 plus 3 is 14x minus 10. That means I'm going to have to multiply by 7. 7 times 2 is 14x minus 7. Subtract that. We don't really care about the remainder, but we'll go ahead and write it down. So we get 10 minus 3, and our slant asymptote is y equals 3x plus 7, which we remember how to graph. Remember, we go to 7 is right here. That's our y-intercept, and then the slope is 3, so it's like up 3 over 1. So if we're going the opposite direction, look how close it's going to cut to the actual points that we already have. That is very, very close. So let me draw that line. Okay, there's my line, and try to make that, imagine in your head that that green is a dotted line because it's an asymptote, but I'm going to leave it there so that you can see it. Now notice, let me change this color. I want something that's going to stick out. Obviously, we had this point right here at negative 2.5 and 0, and then we have this one at 2/3 and 0. And then we've got to draw our function. Now the range is going to be all real numbers again, because there's nothing saying that it can't be any possible y value. And then the domain, is it limited? We have a vertical asymptote at 0.5. So we're limited that x cannot be 0.5. Oops, that's not a parenthesis, that's a brace. Okay, so what you can't see by looking is what this graph really looks like, but I encourage you to go ahead and look at it on your graphing calculator. If you change your window to be really far out, then it might look a little more interesting, because actually what's happening is that this graph is not doing a lot in the amount that we can see. It starts to curve up here, and this is it's probably not even that drastic, but it's coming down here and getting closer and closer. And then on this one, it's doing a very similar thing, but it's coming up along this slant asymptote and then starts to curve like this. So I hope you've done some of it. I'm not going to show you the whole problem because I want you to give it a try, but I'll at least show you the factoring in 3, 2, 1. So here's the original factoring. You can notice that the x minus 1s would cancel out, and then you could re-multiply through the x, distribute that, and you would have x squared plus 4x over x plus 2. Use this to figure out your x-intercepts, y-intercepts, asymptotes, all of that stuff. And you use the synthetic division because x plus 2 is on the bottom, has a leading coefficient of 1, so you can use synthetic division, and then carry on through the process.